Okay, hello and welcome everybody. My name is Daniel Waxweiler. I'm studying at the Saarland University Media Computer Science, and I will present you a framework which I used in my master's thesis. It's called Certificate Transparency, but first I want to give you some background knowledge. Most of you know, for example, the SSL TLS protocol. SSL stands for Secure Sockets Layer and TLS for Transport Layer Security. And it's the most used encryption protocol currently in the world because everybody uses it. You can see it in your browser by having a look at the log icon. And the goal is to have a secure communication between two entities, for example, between the browser and the web server. And the idea is to provide three properties. We have confidentiality, which means that your communication is kept private. And then we have integrity, which means that the accuracy and the consistency of your data is assured. And we have authenticity, which means that you know who you are talking to. These protocols use X509 certificates, which is a standardization for the public key infrastructure. And on the right side we can now see that we have a browser who sends a hello request to the web server, and the web server sends back its certificate. In the certificate we have its public key, and now the browser takes this public key, generates a key, encrypts the symmetric key with the server's public key and sends it back to the web server, and now both parties know a key and they can communicate without other people knowing what they are talking about. Let's have a closer look at what's inside a certificate. There's a lot of stuff, but the most important thing is the public key of the entity. In our example, it was the public key of the server, and there's probably some uniquely identifiable information like a domain name. And there's also a signature of a certificate authority, which is an organization that creates the certificates for a website or yourself, if you like to. And now another entity can verify the certificate, and therefore this certificate authority has to be trusted by both entities. Unfortunately, this system has some flaws. As you can see in the following example, in 2011 the Dutch certificate authority DigiNotar was compromised. Hackers got into their system and they created at least 531 false certificates for a lot of popular domains. You can see here on the right side Google domains. We have also Tor down here, and these certificates were then used to conduct man-in-the-middle attacks in Iran. They were only revoked months later by the operating system and browser manufacturers, and at the end this certificate authority lost all their trust of the clients, of the customers, and they went bankrupt. Let's have a look at what can go wrong in general. The certificates can be issued by certificate authorities that are compromised, so, which means that hackers got into the system and just create certificates, and they could also issue certificates by mistake, or they could even turn evil. You never know. They might also be blackmailed by the NSA, and then they won't tell anybody about it. And then the certificates are used most of the cases to conduct man-in-the-middle attacks, so they can just look what you are sending to websites where you think it's encrypted, but you nearly never detect it because most people don't look at every certificate details. But fortunately, there's a solution for that, and it's called certificate transparency. It was invented by Ben Roy and Adam Langley, working at Google. Currently, it's an experimental internet engineering task force standard, and the main goal is to detect false certificates issued by certificate authorities in nearly real time. Let's have a look at its components. We have three components: logs, monitors, and auditors. The logs are at the heart of the system. They use a cryptographic mechanism called Merkle hash tree. In this tree, you can see on the slide, I've put a small Merkle hash tree. The pieces of data are in the leaf nodes, and then in the non-leaf nodes we have hashes. And the one hash, this hash, for example, is calculated from the values of these two pieces of data. And this structure allows us to quickly verify the integrity of the tree, and you could even verify it in parallel, because imagine there are more branches down here, then you could check this one and this one at the same time, and then at the end you just need to check the root hash. And this also enables to quickly check if a piece of data is inside the tree. You just need to look at the logarithm of the data that's inside the tree. Yeah, and they are currently used for the certificate transparency logs, and there's also a restriction. The certificates that are added to these logs cannot be deleted or edited afterwards. It's an append-only record. And these logs are also cryptographically assured, which means you can check if the integrity is alright. And they are also publicly auditable, which means that everybody can just query these logs and see if the particular certificate has been added, or if the log is behaving correctly. Then we have the monitors, which act as clients to the log servers by regularly copying everything that is new, and they constantly verify these logs by checking the Merkle hash trees, and they can also act as a backup for the log servers, because they have a complete copy of them. So if the logs are offline for a certain time, others can contact these monitors instead. Yes?
Excuse me, who creates these logs?
That's a good point. The logs are run as servers, and most of them are currently operated by certificate authorities or governments. I will come back to this in a few slides, then we will see how it is used today. First, we will have a look at the auditors, which is the third component. They act as clients to the log and monitor servers, and they can verify the logs in total, or just check if there's a particular certificate. They can easily be integrated into end-client applications like web browsers, for example. Now let's have a look at how this works in the real world. On the top we have a certificate authority which creates certificates, and we have a domain, example.com. The domain owner requests from the certificate authority to get a certificate, and this certificate authority generates this certificate, sends it to the certificate transparency log at the right, and this log creates a signed certificate timestamp, abbreviated SCT, and it's just a promise to add the certificate to the log server within some time period. And then this SCT is appended to the certificate and will accompany the certificate during the certificate's lifetime. This certificate is then sent together with the SCT to the domain owner, who could run a web server, for example. And during the TLS handshake, which we saw previously, this certificate is then sent with the SCT to the TLS client, and this TLS client could check if there is an SCT, or even check if it is valid, and could also act as an auditor. And what else is here in slide, you can see that there's a monitor and an auditor. They are also, it's just there to show that they are communicating with the log, and they are can also exchange data between monitors and auditors. Currently, there are 14 logs operated by Google, Symantec, ISNP, Thirdly, and many more. In browsers, we have some partial support. In Google Chrome, which is based on the open source web browser Chromium, there are the checks included. So Chromium can check if the signed certificates are there, have been appended to the certificates. And currently it's even obligatory for extended validation certificates to have SCTs appended. Normally you see here in the image, you have a green box around the log icon and the name of the company. But if there's no SCT, this box will not be shown, but just a normal log icon will appear. Mozilla hasn't announced any schedule yet for Firefox, but there are some code changes in the pipeline, and from Microsoft and Apple there's no announcement yet. My master's thesis was then about enhancing the integration of certificate transparency in Chromium, in which Google Chrome is based on, and I wanted to make this information accessible for the developers. And therefore I started with researching about the certificate transparency framework. I wanted to understand it, and then I had some first ideas in my mind, but as these ideas were strongly biased by myself, I just ran some focus groups. I invited people and discussed with them how they wanted to see this information and what could be important for them. And by running them twice, these focus groups, I defined some requirements and even refined them by the second step, and then I implemented it. After the implementation, I did 2 evaluations. First, I did a software walkthrough with a few people. I just invited people and showed them the new features, and they commented on it. And the second evaluation was an online questionnaire. I took screenshots of the new features and just asked people, how do you like it? How safe is this website? And then they could also answer by just saying what they are missing or what is superfluous maybe in these features. And afterwards, there were mainly 2 features implemented. I will show it you in a bigger slide. Currently, you can see in the developer tools the new security tab. It's only a few months old, and then when you visit mozilla.org, for example, you can click on the main origin and you see information about the certificate. And currently, this certificate has 3 signed certificate timestamps added, and I added this paragraph with more details about it. First, you only see the name, where it comes from. It's embedded, in this case, in the certificate, and it's also verified. And then when you click on show full details, there will be more details for the advanced users. I also implemented an error page, which was generated during the focus groups. People had to draw what they imagined of being informed, and it is a bit different than the usual error pages you know from Google Chrome maybe. They wanted a more dangerous image, and I added 2 options, reload and back to safety. And in this, I changed the text a bit, and these 2 paragraphs, the last 2 paragraphs, are only for expert users, and they are only shown if you have a setting enabled. So normal users wouldn't see these paragraphs, but here they could open the security panel and even go to the probably fake website. And to sum up, I just presented you the SSL TLS protocol. We saw the public key infrastructure with its flaws and also a solution called certificate transparency. And I shortly showed you what I did during my master's thesis using a user-centered iterative design process to improve the certificate transparency integration in Chromium. Thanks for your attention. Do you have any questions? Yeah.
I was recently looking at a couple of my own websites, and I noticed that the stuff I have with Let's Encrypt are the only certificates that don't have certificate transparency records anywhere. Is there a way to publish or to get them listed, or how is that information gathered? Do the certificate authorities, in this case Let's Encrypt, send it somewhere? Or?
Yeah, there's three possible ways. The simplest way is that the certificate authority just does it as I showed in the on the slide, that it sends it to the log servers, and then it gets this SCTs back. But there are two other ways which I didn't present now, but you can check them on the website of them. They are a bit more complicated because you need to change some parameters on your server, and then you also need to upload them to these log servers. But it's possible, you can do this afterwards.
Interesting. Oh, okay. And I might get back to you on that later too.
Okay.
Thank you.
You're welcome. Yeah, there was another question?
Yes,
Okay.
So previously we had the problem of deciding which CA we want to trust, and now we have a problem of finding which logs we want to trust.
Yes, and we have.
So are we always resolving it?
Yeah, you have different criteria for the log servers if to be trusted. For example, a certificate is currently only trusted in Chromium if there are 3 SCTs available, so added to the certificate. But you are right, it changes the checking just to the log servers, but if there is no SCT, then you can be pretty sure at one stage in the near future that the certificate might be alright, but it has been it is just fake.
Yeah, you can put it for log server.
Yes, you could create your own, but in Chromium they have very strict standards of integrating them into their own, in Chromium.
Like they do for CAs.
Sorry?
Like they do for CAs as well.
Yeah.
So,
yeah, if they could also, you never know what the NSA does, but they could be hacked or forced to include log servers that are not trusted. But everybody can also check this log servers if they are behaving correctly. So if a certificate has been deleted or added afterwards, you could also scream and just maybe run a monitor server and look if the log servers are behaving all correctly.
More watchers, watchers.
There's another question at the back.
A certificate revocation list. Are the EV extended verification certificates, are those required to actually verify that the certificate has been revoked with that list?
Yes, this is an extension. It will be added in this first version of the certificate transparency framework. The certificate revocation mechanism isn't very efficient, but they will expand on that. Currently, if a certificate is revoked, then the browsers or the operating system just sends a list to your system, and you would then see, okay, this certificate has been revoked, but the log servers are not touched, so they wouldn't be.
And currently, none of the browsers by default ever check certificate revocation lists.
Okay, I didn't know that.
That's why I asked.
It takes way too long. It's too slow.
Oh.
That's why it's currently not on by default in any of the browsers.
Isn't it true that it's that you get the full list that you cannot query for MI on it?
I have no idea
I believe that's how.
what the reason was for it being so slow, but it's currently too slow, so it's disabled by default.
I have read about a paper where they try to make it more efficient and include the certificate transparency part, but I don't remember the name exactly. I can look it up. Yes?
I think one major thing that this gives us is transparency. So, like before, every CA could just create certificates and not tell anybody about it. And these public logs are a good way to find out at least. So you might be fooled for some minutes, but then you can quickly see, oh, this CA is giving out dumb certificates, maybe we should just stop trusting the CA.
Yes, exactly. And I think a lot of networks, for example in China, wouldn't work anymore if the browsers would integrate this feature.
Well, and probably Startcom would be broke, because a couple of weeks ago, Startcom started a new service which works kind of like Let's Encrypt. Called it Start Encrypt, and they were dishing out certificates for Google.com within minutes. Something went wrong in their authentication mechanism, can't remember.
Okay, is there another question? Thanks again.